Yeah, my name is Aihua. I work for Snowflake and on Data Lake, basically Iceberg team. Yeah, actually, I worked on Hive, HDFS, and Yarn before, but recently joined, like actually 2 years ago, joined Snowflake, and right now actually try to work on Data Lake and Iceberg. And currently, I try to work on variant-related stuff. That's kind of like we are collaborating with open source. Try to drive that, especially like with Databricks folks like Daniel. Today, I'm gonna take this opportunity to give an update on variant and especially on the metadata side. Yeah, here's the agenda. So basically, I'm going to give some introduction and background on the variant data types and shredding. Then some part of like a metadata. And later, we're going to talk about some metadata enhancement and also like project progress. Yeah, I think it's already kind of a long day. Hopefully, you guys still feel like energized. But of course, at night, like we're going to have very good food. Yeah, today. Yeah, first, like, what is a variant data type? At Snowflake, actually, we already support a variant for a long time, actually, for internal format. When we start to support Iceberg, actually, we got a lot of asks, can we add to Iceberg? Without that, we cannot migrate to variant. We cannot migrate to Icebergs. Of course, to Iceberg, it's for obvious reason, right? They don't want to log to a particular vendors. That's kind of like major reasons. So that's why like we start to propose the open source and then continue to drive forward. So like variant, it's kind of like to represent a semi-structured type. I think like Daniel or we have like give a little bit of a variant. So it's kind of like to represent semi-structured data. For example, XML or like JSON. Actually, most like a JSON data type. Of course, for variant, it's not only to store, let's say JSON, or like you can store primitive types as well in variant. Basically, variant arrays objects can be stored in variants. Like why we kind of like try to introduce variant in Iceberg? Of course, one, as I mentioned, a lot of asks from the community. Try to achieve like parity with other engines. Like I know Redshift also have like similar concept of like super data types, which is a variant. Snowflake also supports variant as well. And Spark actually recently just add variant support. To add to Iceberg, the benefits of that is, we're gonna standardize encoding, decoding, and standardize like shredding those kind of specs rather than each engine to introduce its own formats, right? Which will cause like compatibility issues. Like if you want to move from one to the other, then you have to kind of load the data. While we standardize the variant data type in Iceberg, then you don't have to kind of you point to single. It's kind of like single copy. The third one is, of course, we can support many more scenarios, which involves semi-structured data. Some high-level tasks for variants. In order to support a variant, we need to support like encoding, decoding. We have to define the format for variants. The second area is shredding or subcolumnization. Actually, at Snowflake is called a subcolumnization. The shredding actually is kind of like for the optimization. Without shredding, you can have like variant to work. You can read and write variants, but shredding is kind of bring to a next level, which is like you kind of extract the data from variant data to store as a separate columns. That's kind of like, I'm gonna talk a little bit more later. We can have like additional metadata. With that, we can do more optimizations. Yeah, so third is like a metadata enhancement. Of course, it's kind of like high level things. We have way more around Iceberg. Like for example, if you want support in Parquet, right, you have to add the types in Parquet or in Avro. Like through the talk, maybe I'm gonna use this kind of examples. So I'm gonna like just use like some data to show what does it mean, for a variant. So as you can see, like we may have like different format. Let's say for ingestion applications, right? You receive some events. Like for example, event type, it could be a string type, or could it be a integer, or could it be a long, right? Or you could receive an error response. It's kind of like it's not the same data format. So that is kind of like a good use case for a variant. You kind of load that into one column, and then later on during the read time, you kind of like parse that out based on, it's kind of like parse time, you can have a schema. And here I also kind of include a nested array and objects as well, just like to show how it looks like. Like when you try to use, here is example. You can create a table with variant column, and then if it's a JSON, you can just like pass JSON, to load the data. During the query, you can use such kind of like format, to access a sub column or sub fields, and convert that to, let's say, string or double, based on stored data. Of course, this is kind of like a Snowflake format. Spark actually has a slightly different syntax. So then let's come into the encoding, decoding part. We use for basic variant support, it's stored in two binaries. One is a value, one is metadata. There's two fields. Like the data, as we mentioned before, like primitive type, array type, or objects can be stored in variant. For primitive type, each of them has a type code. Of course, for details, you can get to this link to find more information, but it's kind of like just like give like very high level introduction. We can store int or string in a value data. For arrays, it's a little more complicated, but I refer to the spec for detail. Like for object keys, now we know like the keys will be duplicated, right? If we if we store the keys, strings in the values, then the value field will get large. So what we do is we're gonna encode the key, object key in the metadata as a dictionary. So for example, key event type, we're gonna store that in this dictionary with ID 1. And then we can, in the value itself, we can refer to that ID rather than event type in the value. So that's kind of like for space saving. Yeah, that's kind of like a basic encoding. Now let's talk about shredding. Like with just like basic, with just a basic variant encoding, decoding, we already can achieve some of performance improvements because of the like encoding methodology. We don't have to scan or load the whole data to access one field. We already can do that, but shredding is one step ahead to kind of like extract fields as a separate column. We call it subcolumn. With that, we can achieve, a couple other benefits. For example, file pruning. We're gonna also build the metadata. I think Sandeep also kind of like talk a little bit of like metadata, right? So for subcolumn, we're gonna also do the same thing. We're gonna like collect the metadata. With that, we can prune the files, which is like not falling into the min-max, for example. And also, because we extracted the subcolumns, when we try to access a subfield, right, you don't have to access the whole variant data. We just access the subfield column. So that's kind of like a reduce the data access. The third one is storage optimization. If you store the variant alone, it's just like binary, right? There's no pattern or something. Then pretty much you cannot do optimization, let's say on the packet or like org level. But if you extract the subcolumns, for example, event types, right? Or it's logging, or log out, those kind of things, right? Then packet, I think we can do like more optimization and save storage. Like here is like a shredding process. Basically, for each file, let's say for a column, we have like 1,000 or 1,000 columns, right? 1,000 data. Now, like how do we like shred subcolumns out? So basically, we're gonna based on those 1,000 columns, 1,000 data, to decide what kind of fields we can shred. So that is kind of like engine specific thing. It's not like in a spec. Actually, spec doesn't define that. For example, Snowflake or Spark, actually they may use like different algorithms to do that. One other example may be like I'm gonna choose top 100 fields, which like the path, right, which is top 100 fields appeared in the data, something like that. Or maybe as simple as I'm gonna use the first variant data I'm seeing, right? All the paths I'm seeing in there, I'm gonna extract, something like that. The second task is like to determine the shredding type. So as I showed like in the previous examples, right? For example, event type can be string or can be int. Now, how do we decide which type to use? one example can be most common types. I can see like a lot of strings. Then for event type, then maybe I can choose string as shredding type. The third one is I can extract the values, shred the values into subcolumns. So basically, if the field value matches the shredding type, then I can shred that into typed column. What that means is, let's say for event type, I shred into string, right? And the value is login, it's a string. Then I'm gonna put that into shredded typed column, string column. With that, you know, if everything is string types, we can collect the min max or all those kind of stats. So it's just it's going to work as a regular column, right, to do a lot of optimizations. Now, if somehow some of the data cannot be shredded, then the remainings will be encoded in its original data type. For example, 1, right? Event type equals 1. It's int. It cannot be shredded. Then it's going to be encoded in untyped column, which is still like int type. Yeah, here maybe like I'm gonna give an example. Maybe it can be a little bit easier to understand. So let's say the engines decide, oh, event type, I'm gonna shred it to string, and an event timestamp, shred to string timestamp. Email is shred to string. Here you can see like event type. This is like typed column. We're going to have like login in this column, similar for event timestamp. Now, since we are not shredding note column, then it will be saved in an untyped column, which is kind of like the binary. Then you cannot do further optimization with this column. As I mentioned, since this is a 1, right? Event type is 1. Then when we shred this, it will be kind of null. We will not be shredded, and then it will be saved in untyped field. Yeah. Now let's come into the metadata. Of course, Iceberg has like file-level metadata or table-level metadata, but this doesn't change with variant. I'm gonna more focus on like column metadata. For example, like we have like value counts, non-value counts, min max, lower bounds and up bounds. Those metadata can be used for like file pruning or aggregate functions. But just as we mentioned, let's say Parquet, right? It may not have exact min max. It has a field to say, oh, if this exact or not. But I think the Iceberg doesn't have that yet. So I think we just like still use that. Maybe in the future, we can still, we're gonna add that kind of support, say, whether it is aggregates or lower bounds or up bounds is exact or not. So when we collect subcolumn metadata, then we're gonna achieve the same benefits for subcolumns. Here, I kind of listed like 2 examples which can benefit from subcolumn metadata. For example, if you can have those kind of filtering, right? If it doesn't match this condition, then the files can be pruned. Or we can have this aggregate functions. So for like column metadata, it's stored in Iceberg manifest files. And the type, like we store like map to column. We store like a map of column ID to stats. For example, for lower bounds, it's a column ID to lower bounds. Because the data can have different types, right? So we convert that to binary. For null-value counts and value counts and the others, it's kind of like long, it's a long. Yeah, please observe that it's kind of like binary. Because of that, what in V3, right, what we are trying to propose is for subcolumn metadata, we're gonna collect lower bounds and upper bounds for subcolumns. And then we try to encode them into a single variant. Yeah, something like this. Like, let's say for event type, it's all strings, right? We're gonna have a string type and then the path, and we have a lower bound in here. Then we're gonna encode for each variant all the subcolumn metadata encoded into variant, a single variant, and then convert that into binary. With that, as we just mentioned, since it's a binary, we will not introduce compatibility issue in V3. For like other stats, like value counts, if we want to introduce in V3, then it's gonna break. It's gonna have a compatibility issue because currently it's a long type. It's not a binary or something. Now, for metadata generation, here are some of here like are the scenarios. If for a subcolumn, if all the types, it's kind of like on the file level for each file. If all the types are, let's say, string for event type, then we're gonna collect the lower and upper bounds. Or it's an integer, right? We can collect the lower and upper bounds. Now, if it contains multiple types, for example, it has string or int, then we're gonna skip. We will not save. We will not save bonds. We will not collect bonds because even you collect, you cannot use that. You have to like, because of the type promotion, right? You have to check. You cannot directly use the metadata. You have to check the column, the data, and then see if you can promote to the types you are using, you need. Now, if some values are null or missing, we still collect that because that's still kind of like valid. We can still use that to do to do like pruning or answer aggregate function. For the future improvements, this is more like targeted for V4. That's what we are thinking. We're going to try to expand the support to additional stats like value counts or null counts. I guess like that's going to be incompatible change. So that's like why we are trying to push for like in V4. And also in V3, they probably will not have like type promotion because for lower bounds and up bounds, we don't save the type in manifest file. Now, because of that, well, currently we have a certain type of promotion paths for Iceberg types. For example, from int to long, then we kind of use the data width to induce what is your original type. But that is not true for variant because a variant size can be, I forgot how many bytes to like very large bytes, many bytes. So we don't know like what is a original type. It's a variant, or if it's an int, or if it's a long type. We don't know. So that's why we will not support type promotion in V3. But in V4, right, we can think of like store data type in bonds, possibly. With that, we know, oh, what is your original type? What is your new type for each file? Of course, we need to handle incompatibility because it will not be compatible with like V1, V2, V3. Yeah, here is kind of like thinking, how we're gonna store like stats. One, probably it's kind of like similar as what are we gonna do in V3. We can store them in a variant, or since it's an incompatible change, maybe you can do like a big change, which will like kind of group all the column stats in one structure, and then I'm gonna have like column ID to column stats. Yeah, but I think we need more discussion on that. Yeah, here are some like real world use cases. Yeah, one probably like ingestion, right? Data ingestion. If you want to ingest the sensor data or something, which like if it's a unique schema, then probably you can use like kind of like a table, right, to handle that. But if it's let's say for example it's a mixed, you have like errors or something. Instead of like add the logic in your application, maybe you can load that into a single column, a single variant column, and then later, you can handle. Let's say I want to handle errors, or I want to handle like type like version 1 event or version 2 event. You can do that separately. And also, for example, there's logs, right? A website logs probably varies a lot. Then you can load that into variant data type, variant columns as well. Here is like I want to report the current progress. The first is like a spec. Actually, we kind of like adopt Spark variant. Initially, we were thinking, maybe Snowflake has its own implementation. It's proprietary, right? We can propose that. But Spark already have an open source implementation and a spec. So we're kind of debating, which one to do, to propose. Later, we think, oh, maybe just go forward with Spark version. It's kind of like similar. So we don't want to introduce a lot of like debate on that. So right now, the initial version from Spark is already in Parquet. Oh, actually, the spec is in Parquet. It's not in Iceberg. And we are also like working on improved version. And right now, it's under review. Second is like variant data type support. That's kind of like basic variant type support without shredding. The type is already added, and like a reference encoding or decoding implementation is already merged. We have like encoding is under review as well. Of course, if we want to support the full stack, we have to add support to Iceberg, Parquet or Core, a lot of like libraries. It's still going. Yeah, for shredding, actually, we kind of like started, but it's just started. Yeah, right now we are working on like a metadata part and try to do POCs, and also we need to add like shredding and reconstruction, because when you shred to multiple subcolumns, right? But what about I want to select event, right, which is the full variant, right, and to reconstruct the variant data. The last is like we need to do like integration with Spark or all kinds of engines. Like different engines, of course, needs to add that support at the implementation. And also like if you want to export to Parquet or variant, then those storage needs to add logical type. Finally, this is like a community effort to drive this project. I'm just like contribute a little bit on that. If you want to contribute, you can reach out. Of course, Dan also shared community link, right? You can also reach out to us from there. Here are some of the references. Yeah, actually, there are more of that, but this is a kind of like more related ones. Yeah, I think that's pretty much pretty much it. This is an ongoing effort, so hopefully after some time, I'm gonna report back on the development. Yeah, let me know if you have any questions.
So you mentioned that there's a spec. I assume this has to be rolled up into the larger like Iceberg V3 or V4 spec. What parts are you targeting for which specs? Like, I assume that since shredding is very new, that maybe the V3 would just have the first part, or like, what are the thoughts on how this will roll out?
Yeah, maybe.
I mean, like, I'm not asking for guarantees. I'm like, guess.
Yeah.
Like,
so
what's the feeling? What are the vibes?
Yeah, I mean, in the Parquet community, and the first part of it is like adopting the spec in Parquet, because we want to make sure that we have consistent representations at that level. And so right now, the conversation is about wanting to adopt both the variant specification and the shredding specification at the same time, because they're close enough, and we would like to get to a point where they're both being used. So they are pretty close. I think that there's some small subtle things that we're working on in terms of the shredding specification and just formalizing that. It's a big community effort. We're working with Google and Snowflake and Databricks and everybody to try and nail that down. But the intent is actually to kind of roll them at the same time.
And like V3, V4?
As part of V3.
Okay.
Yeah, so right now, Parquet requires some reference implementations, and so we're working on donating one of the existing Java ones from Spark and getting that up to speed. And then we're looking for other implementations, and there's been discussion in both like Arrow community around Rust or C++, and there's also a Python implementation out there that we're looking at. So it's just kind of a matter of like, when can we get enough reference implementations to satisfy the Parquet community's requirement of multiple implementations.
And bailing on Orc?
We would love to have somebody contribute from org.
Not me.
Yeah, actually, when we proposed, we were thinking of just add the variant data type first, but the community side need to combine both because they see the benefits of shredding. They were saying, oh, without shredding, probably it's not that much of use, so we'll try to combine them in together. Yeah.
It's a big lift.
Yeah, that's true. Yeah.
So you mentioned about shredding that you're going to be shredding like top 100 fields or something like that. How is that top determined? Like, is that based on the frequency of access or just in the order?
It's not well, actually, you cannot have access because that's happened during write the files, right? So basically, it's based on the field, the paths, how many paths have occurs in let's say 1,000 data. Let's say if event type happens 1,000 times in all the data, right? Then maybe it's a candidate. Do you follow what I mean? So basically, based on how, the occurrence in each of this data. It's not about access.
Okay.
At that time, it's not it's write time. It's not read time. Yeah.
And is there a way for customers to give a hint, like what fields you can shred and their data types?
Sorry. What was that?
Is there a way for customers to provide a hint, which fields you should shred and what should be their data
Yeah.
types?
Well, that's kind of like well, of course, this is up to the engine to do that. It's not in the spec. Spec actually doesn't provide that. So yeah, if engines implements that, of course you can do that. Yeah, there was some kind of a discussion about that. Maybe like, for example, whether I should limit number of fields, right? Something like that, or give a hint on like what kind of paths, or maybe I specify which fields should be shredded. Yeah, that's all up to the engine, actually. Yeah.
Thank you.
Yeah. Thank you.
So, follow-on question to that. Follow-on question to that. So on the shredding, is there a downside? Like you don't want to shred everything, but you want to shred only columns that are interesting from a query, like predicates, joins, and so on. So just follow on to that question is that true? There is a downside to shredding too much and being able to, after ingestion, actually being able to specify based on the workload that these are the interesting columns.
Yeah. So, for example, one downside I can think of is like you need to collect the metadata, right? And then that metadata gonna be stored in, let's say, manifest file. Then that manifest file gonna be large, right? I think it's in Daniel's presentation, right? I mentioned, like large manifest file, right? That's gonna be a downside, for example. Let's say before you only have like 100 columns, but now with variants, let's say you have like 10 variants, and each of them you collect 100 fields, right? And then you're gonna be like 10,000 of subcolumns, and then you collect the metadata. The manifest file will grow. Yeah, for example, this is kind of one downside.
Right, because at ingestion time, you may not know enough about the workload patterns to know what to shred.
Yeah, that's true. Yeah, then probably, like as we just mentioned, when engine implements that, they may take some of the hints, right, to do, or maybe specify some rules or something. Yeah, unfortunately, like during write time, you don't have such kind of information otherwise. Yeah.
Thank you. Great talk.
Yeah. Thank you.
So, Aihua, nice talk. Thank you for your introduction on variant. So my question would be, can you provide, I know every user I want to use this feature, can you provide moderate timeline when the V3 spec will be finalized? And when the engine will support, is it Snowflake that has a timeline, or is it Trio has a timeline? Yeah.
Yeah, well, I think like Daniel like already kind of mentioned, it's kind of an ongoing. Cannot give like a timeline for V3 or something, but
Not even moderate timeline. I'm not asking you aggressive.
Yeah. But of course, like each engine, I guess, have its own timeline. I guess. Yeah. For example, Snowflake definitely have its own timeline, to deliver things. That's why we kind of actively work with community to push forward. Yeah.
So 2026?
Yeah, I guess probably. I mean, for Snowflake, I guess try to do something in this year. I guess.
That's the manager's question.
Yeah. That's true. Like, right. That's true.
My memory is column IDs are allocated globally and assigned globally. So that would mean that the shredded columns would have to be pre-decided, or you'd be like adding new column IDs as you go, and like you may run into like column ID exhaustion.
Yeah.
But the one nice benefit would be like when you're writing, you'd go look it up and be like, well, these have assigned column IDs, so therefore I should be shredding that way. But that doesn't really fit with what you described.
Yeah, go ahead. Oh, okay. Yeah, well, that's a good question. Yeah, actually, like for sub-columns, we will not have IDs. So what we do is going to be have top column ID plus pass to have that. Yeah, so yeah, I think that's kind of like a valid question, right? So we will not have that.
Yeah, so the representation in Parquet is that like for variant, there's the 2 columns. Those have field IDs, but then anything that's within the actual variant structure, they don't have global field IDs because each individual record can have a different representation. So yeah, there's no way to track that.
It's going to be a lot.
Yeah, yeah.
Okay, thank you.
Yeah, thanks. Thanks a lot.